Hello everyone, welcome back to my channel. I am Anushka Srivastav. So this is my fourth lecture in my data science series. So let's see what are the topics that we are going to discuss today. Today we are starting with data preparation phase to model the data. So let's see what do we understand by data preparation. Data preparation is essential before training a machine learning model as it ensures that the data is clean, balanced and ready for algorithms to learn effectively. Proper preparation improves model performance and help prevent issues such as overfitting and underfitting. Imagine we have a dataset containing customers' information like age, income, education and credit score. With the target variable indicating loan approval yes or no, we will use the dataset to walk through various data preparation steps. Step number 1, partitioning the data in Python. Partitioning data involves splitting the dataset into training and test sets. The training set is used to train the model while the test set evaluates its performance and unseen data. Goal: use the training set to train the model and the test set to assess its performance. So consider this particular example. In this example, we will partition the bank additional dataset into training and test set using Python. Goal is to machine learning to evaluate the model's performance on unseen data. Step number 1, importing necessary libraries. First, we need to import the required libraries. We will use pandas for data manipulation and train test splits from sklearn to split our dataset. Step number 2, loading the dataset next. Next, we will read the dataset into pandas data frame named bang. Make sure to replace the file path with the actual path where your dataset is stored. Read in the bang additional dataset. Step number 3, partitioning the dataset to partition the dataset into training and test set. We will use the train test split function. This command creates two new datasets, bang train and bang test. Step number 4, confirming the partition to confirm that the dataset was partitioned correctly. We can check the shape of original dataset, the training set and the test set. The output will give you three tuples. Each tuple contains two values, the number of rows and the number of columns. The first number from bang train shape and bang test shape output should sum to the first number of bang shape output. The first number from the bang test shape output should be approximately 25% of the first number of bang shape output. For example, the original dataset has 1000 rows. The expected output should be bang shape 1000, x, bang train shape 750, x, bang test shape 250, x. This confirms that 750 plus 250 is equals to 1000, that is the total score. How to balance the training dataset in Python. Step number 1, data balancing problem. Our data is uneven: more, no for reject and less, yes for approve. If we train the model like this, the model will be biased and will reject more. Solution: we will upsample the minority class so that both the classes becomes equal. So in this particular program, we will upsample the function. Here we will separate majority and minority classes, upsample minority classes, combine majority classes with upsampled minority classes. We will print to check balance of new class. First, we separated majority classes and minority classes. Then we upsampled minority classes so it is become majority winning. Then we combine both the classes and create balanced data. How to build card decision tree using Python. Card, that is classification and regression tree, is a decision tree algorithms that can be used for both classification and regression tasks. It constructs binary trees by splitting data into subdata based on the features that results in the best separation according to criterions. CART, classification and regression tree, is a popular decision tree algorithm. It splits into subdata based on the feature provided, providing the best separation measured by the Gini index. Example: predicting loan approval based on customers' information. Import necessary libraries, train card decision tree model, make prediction and evaluate, Building C5.0 decision tree in Python. The C5.0 decision tree model restricts the tree depth to prevent overfitting. This control ensures that the tree captures general pattern without excessive details. Building random forest trees in Python. Random forests build multiple decision trees and combine them from more robust production. This approach reduces overfitting while improving accuracy. So here I am ending my lecture. I hope all your concepts are clear. We have covered each topic briefly. See you in the next video. Thank you.